Hello everyone, my name is Harold Campos, Principal Program Manager for Azure Integration Services, and today I will explain how we can speak with mainframes with Visual Studio. Okay, so first of all, how different are mainframe programs and environments? One major difference is that mainframes run on EBCDIC, not on ASCII. Also, that COBOL is the most known programming language for mainframe systems, so it will be very natural for you to find COBOL programs everywhere. But now, that is what you have today. I mean, why is it important to understand, what resides on a mainframe? If you're integrating with mainframe systems, oftentimes you will work, you will call HTTP services, you will call REST services, or some services, web services, right? But the fact of the matter remains that web services are not pervasive for these types of environments. So then you still need to interact with these legacy programs and complex data structures. So then what you do need is something that allows you to interact with these programs and data from a developer friendly environment or a low code environment perspective, right? So then it would be ideal for you to have something like this instead of working with these nested structures, right? And doing complex coding on it. So then to have something like a facade, like it's like this structure that I'm showing you here, which is something that we're going to be speaking about, that you can create with Visual Studio. Now, um, from a mainframe integration perspective, I was just mentioning that COBOL and RPG continue to be the most used languages in these environments. There is a concept of a copybook or a copy member that's basically a piece of code that holds on a structure of a program, the information that it exchanges, or that is shared with by developers to express how is it that a program is expecting some data types to the data types and the data that is expecting to work with other programs. So COBOL copybooks or copy members remain to be a great way for mainframe developers to reuse definitions. So regardless of the communication method used to access mainframes and mid-ranges, data conversion remains being an issue. So that's the reason why it's key to have some element that will um, serve as a basis of or a contract, so to speak, right, between programs that are accessing these legacy systems. Now, many years ago, we released a feature called the TI Designer in Host Integration Server that has the ability to map these data and programs um, to .NET objects, right? So what we've been working on over the last few months is we've been introducing those capabilities in what we call an standalone designer for Logic Apps. So basically, we have abstracted all of these capabilities of the TI Designer and Host Integration Server. We have isolated them, and we have created a tool that makes you create these mirror objects of what you have in the mainframe from a data or program perspective. So in other words, with this tool, you're going to be able to create these programs without installing Host Integration Server. So you just download the HIS Designer for Logic Apps, which is available in the Microsoft Download Center, and install it with Visual Studio, and then you are ready to create these mainframe and mid-ranges artifacts. So the HIS Designer for Logic Apps is a tool for the developers to associate .NET data types with COBOL or RPG data types for a host application or data. It is installed in Visual Studio and supports host applications such as CICS and IMS, and also host files. And it allows importing or exporting the data definition section of the COBOL or RPG code, making up mainframe transaction programs or the copybooks. Right. So then, if you see here on the right side, you have Visual Studio. You have a way to import these definitions, and you can also create them from scratch. Now, if we drill down a little bit on the capabilities for CICS and IMS systems, the HIS Designer for Logic Apps supports CICS and IMS. This is applicable for Host Integration Server and for Azure Logic Apps. There is a concept of a programming model, right? So the way how we integrate with all of these different types of systems is governed by the platform and by the protocol, and also by the amount of data that can be exchanged, and other variables and factors. So that is what we encapsulate in what we call a programming model, which I will be providing more guidance later on in this presentation. But they determine how mainframe programs are accessed and the characteristics of the interaction between both platforms, the mainframe and the non-mainframe platform. Azure Logic Apps supports only TCP and HTTP programming models because the additional programming model that we have, they are based in LU 6.2 or APPC, and they require the SNA gateway, which is something that you will have to stand a host integration server machine to provide those capabilities. So then you have three protocols: TCP, HTTP, and LU 6.2. With the connectors in Logic Apps, we support the first two, and with host integration server, we support the third one. Target environments, you have CICS, IMS, and the platform for SystemZ, SystemI, and DPC in iSeries. In ELM link, for instance, we have for CICS, we have user data, you have TRM link. All of these are specified. They are in the definition of the programming model, so I'm not going to be drilling down on the characteristics of each one of them. But I just want to stress out that you have multiple options to integrate with these systems that go beyond just calling a REST or a web service, right? So, which you can do, right? But if you want to do a more native, low-level integration in a low latency environment, so then it's very convenient for you to analyze all of the options that you have for this type of integration. Now, we've been talking about, that you have a mirror of the mainframe program or data, right? But let's start. Let's drill down a little bit on the things that you can do with the HIDX designer for Logic Apps. For instance, if you create this definition for a method, you have to extract data from an employee, right? So this employee, you have here a library, you have the interface, and you have the employee, and then you have these three parameters, right? One M code, another one M age, and then M years with company. For this M code, you will see that the type of this parameter is M details. For this M age and employee years with company, they are short, right? You see that you have the ability to specify the direction, either in or out, or a return value if you were to have a return value, right? And the host data type mapped to the .NET data type. Now you see here that you have an M details structure, right? This is the type of M. The type of this structure is M details. So this is a structure type called M details. If you go to the structure section, you will see that M details has two values: M position and M number, right? So these variables, M position and number, they also have a definition, string and short, pick x1 and pick s95 display. So then you see that you can create a definition and a structure that resembles what either you had in the copybook, one of the copybooks that we just presented, or something that you can create from scratch with the mainframe developer. So this is one of the aspects that you can manage with when creating a method for CICS or AMS. Now, expanding the scenarios, you have also the support for host files. The HIDX designer for Logic Apps supports the following files: mainframe ZOS sequential access methods, SAM datasets, visual storage access method, vSAM datasets, and basic partition access method datasets, VPAN datasets, right? And then the iSeries files, the mid-range I files, so iSeries or files. It can be used by the managed provider for host files, which requires SNA to connect directly to the host files, or the host files connector for Logic Apps, which is an offline standalone, an offline parser, right? So it can do the binary parsing for you, right? But it doesn't connect directly to the host because connecting to the technology that we use to connect to hosts is, let's say that it requires a lot of resources. So then sometimes you are better off to just extracting the data from the host and then just placing it in the cloud for us. So then we can do the binary processing of it in the cloud. So you see that you have supportability for System Z and System I. We support COBOL and RPG as well for these copybooks. Let's take a quick look to this schema, right? Because with host files, you define schemas. You have a table, you have a schema, you have a union. Let's say that we have this sample mapping for this table, right? You have to specify for this table that's called sample mapping. You have to specify, this is the alias. You have to specify a host file name. So if your vsam file is called sample.vsam.esds.file, this is what goes here, and this is the name of the schema that you're going to be using with the definition of all of the fields that will actually be used to parse the data you have. So then, in other words, sample mapping becomes just the header of this, but the actual information and the data structure that you need to work on is the vsam file record that you see here, right? VSOM file record, which is a schema, all of the fields, the data types on the .NET data types, the mainframe data types, right? And then you see, if you drill down to, for instance, field 5, you see that this is an structure member that has the definition of a union. And this union that you see that has three members here, right, has as a union type discriminant union. So in other words, this discriminant union that you have here, right, it has a COBOL redefines, and it's defining what we call a discriminant value table, or DVT. That's where this acronym is coming from. So then this discriminant value table dialog allows you to create rules for these members, right, and values, and then these go in cascade to the structure member, and then to the that will go to the union, and will go to the schema, and then we'll go to the sample mapping that you have here. So these are some of the things that you can do, creating schemas and discriminant value tables, right, and definitions with the HIS designer for Logic Apps, which covers many more scenarios, right, that we are documenting, that we have provided documentation. We will be providing links as well in the next slides, and I'll do a quick demonstration on how to work with the designer as well. Importing copybooks, determine you have to determine the right programming model following the guidance here, as I said. So this link is available, so I'll add it to the video as well to the channel. Work with the mainframe programming to obtain the right copybooks. If you have a PL1 copybook, it will have to be converted to COBOL. We used to provide rules for such, so I may be able to add it in a blog entry later on, as soon as I find it. And you have to follow the steps in here to import host definitions. This is some guidance that we have for creating copybooks that we've been using successfully, that our parser also takes into account. So every time that you have a COBOL copybook or RPG copybook, make sure that you follow the standard programming rules for copybooks. Now, before jumping into showing the tool, what is an HIDX file? Because this is a term that you will be hearing across all of the documentation for Logic Apps, integrating with mainframes, or even for host integration server. So, host integration definition XML file is the outcome of the HIDX designer for Logic Apps. So it's the artifacts, it's the ultimate object that you create that holds the mapping structure between the mainframe and the non-mainframe world. It can be used by transaction integrator with host integration server, by the managed provider for host files, host integration server, by the CICS connector, by the IMS connector, and by the host files connector. And remember, our connectors, they are embedded in compute. The built-in connectors, these connectors, they are part of the compute. So then if you're using a Logic App, standard, the standard tier of Logic Apps, so then they are just part of the computer you're using. So you don't really need to pay additional for using these connectors, because they are part of the compute, as I said. On the right side, you will see that you have a number of HIDX files in this Logic App, right, that I have uploaded for a number of applications. So they fulfill different purposes, right? Now, this topic is for the HIDX designer for Logic Apps, but you can also create HIDX files for 3270 using the 3270 design tool, for which I have provided some guidance before, and I have a video as well that is available in the channel. Now let's take a quick look to the HIDX designer for Logic Apps. So let's go, of course, to the VM, right? So let me show you this just in just a couple of minutes. We will see how the tool looks like. So the tool has an installer. So you will go to the download center, and you will download it, and then you will have to install it on Windows, on a Windows that has Visual Studio, right? So I downloaded the HIDX designer here, the HIDX designer for Logic Apps. Welcome to the HIS designer for Logic Apps setup wizard, right? So I installed it already, so I'm not gonna repair or change, right? But you can just install, go through the setup, right? And you have to just be patient because it has to update Visual Studio, and sometimes we take our time when we update Visual Studio. So now let's open Visual Studio to see how this looks like. So first of all, one thing to note is that if you want to create a new project, you will have to write here host application or host files, right? In the templates. So host application, right, or host file, and then you will be able to create this object, right? Host application, for instance, here, and then if I choose host application, I do next. Then I do create, right? So then what's gonna happen is that's gonna bring Visual Studio, and then I'll go to the Solution Explorer, hit Add, and then I have two options: .NET Client and .NET Server. We only use the .NET Client definition. Okay, the .NET Server definition is for host-initiated processing, which is out of the scope of the work that we are doing right now with Logic Apps and also with the designer. So then if I hit .NET Client definition, you will see that, okay, I create this library, add, and then interface, next. Then this is exactly the part where I was mentioning that there are multiple protocols available. I mean, we have TCP, HTTP, LU 6.2, and so on, right? And then you have CICS, ELM link, one of the modules of CICS, and then we do create, right? So once I do this, so then I'll have the option to create my own methods here, right? My own methods and data tables and structures and everything manually. Actually, when we created this feature the first time, the whole idea um, was to have the mainframe programmer and the Windows developer, right, working side by side in creating this definition by looking at the mainframe program in the screen. But then we realized that that was not very practical because everybody's busy, and with the years, this is pretty much impossible to achieve. So we added the capability to import a host definition. So then if I go to the let's say if I go to one of the models that I have for CICS, right? Let me see, CICS. Sample mainframe code, TCP CICS. Okay, this one, ELM. Let's do the ELM user data, right? So if I import this program, right, this program that is available in our SDK that we will be releasing soon, right? So you have the name, you have the link to program name. You can use redefines, you can use the defaults, you can define a method, the data table structure union, right? You do next, then you will automatically have all of the definition for this program available here, right? So then this program, right? This program was immediately created, and the mapping was created by the tool. Now, what if I wanted to export something else, right? For whatever reason I wanna take another program, right? So I'll do this one, TCP. I don't know. This is this one, right? Get accounts. This is the link model, which is different than the one that we just selected. But then anyway, so we'll just take it for the sake of the argument, and then we have the get val mode, and then we have name, account number, and then account balance, and then the data types as well that have been mapped. Okay, now so let's create. So let's do this. Let me delete this, remove, delete. Now let me create something else. Right. So this object, Microsoft TCP, CICS. This is, well, okay. So let's do IMS this time. Okay, TCP, IMS, IMS connect, create, right, and then the same choices. So host definition will import an IMS program definition here, TCP, IMS connect, right, get accounts. So if I import these get accounts, right, you will see that you have a very lengthy program here. So you have the transaction ID. It populates the transaction ID. You can change this, right? That you can change the name of the method as well. And then you will have to select some variables, like for instance, input area here. Okay, so this is the input area. Then what is the output area? This is the output area, right? Next, and then you will select the return value. So you will look for whatever return value you have to return, right? So return value. Let's say values. Look for it. Say that's I'm returning the output area too, right? And then group, I can define this as a group. Let's say that I want the input area to be a structure, right? And then the LL fields, or these are the LL fields for the input area, for the output area, and then the ZZ fields, right? You can ask your mainframe developer to explain what this means and how to set them up in the program. The trunk code field, tran here, right? Run code, and then finish. So then you will see that you have a definition that will include the structures that we just defined, right? And these structures will be mapped to your get accounts. So then if you see your return value here, you will see that you have a group here that has the account info structure, right? So the account info in the output area, right, that has the account number, type, balance, and variant. Imagine doing this on your own manually, or trying to look through the elements of this COBOL program in a binary manner. So that's why this is the real value of the tool, right? The value of this tool is to help you creating all of these map to these complex artifacts, so that you don't have we just did it in a minute or so, right? You don't have to spend a lot of time, trying to figure out how to parse this legacy data. Now let's do something else. Now let's create another project, but let's create a host file project real quick. Host file, and create, and then you'll see that in so what I'm going to do is I'm going to create a host file definition, and this host file definition, it's a COBOL definition. So then it will give me the chance to create a table, the schemas, or union. As I said, I can do this manually anytime, right? But also I have the option to import the host definition. So then if I import the host definition, right, so I'll see if I have a host files definition somewhere, right? Let's see, application integration, app, Microsoft, data integration, host files provider, um, discriminated union, host files definitions. We don't have one here. Let's look in this one. And then you see that you have a COBOL file here, right, that has a structure, right? So then this has a very simple plain structure of a customer record. So this customer record schema, it was created so then you can have a table here, and this table can map to the customer record that you created here. So then you are mapping to this schema, and then you will have to add here the information of your vsam file, right? Sample.vsam.hcampus.123, I don't know, dot file, right? Say, for instance, this file, of course, with uppercase, right? So then you will have this information here, this mapping, and this is exactly what you would be required to fill in the um, from the Logic app, from the managed provider for host files, if you were using the connected, trying to integrate with the mainframe in a connected manner for host files. But well, I hope this was helpful. Going back to the content, key takeaways: the HIDX designer for Logic Apps helps developers to deal with complex mainframe problems and data parameters and structures to create mainframe data artifacts, metadata artifacts. You can use these metadata artifacts manually or by importing COBOL copybooks. The COBOL copybooks remain to be a great way for mainframe developers to reuse definitions, and the outcome of the HIDX designer is an HIDX file that should be uploaded to the Logic app. Thank you very much for your time. If you haven't done so, please subscribe to the channel, and thank you again. You enjoy the rest of the week.